All right, now on the study guide, they're suggesting from chapter 10 that we look at some problems from 10.2. And the objective is to use the fundamental counting principle to solve counting problems. And it said like 41 to 52. So I thought we'd just kind of go through several of these. So line up all 5 of these members for a photograph. So let's think about that. We've got 5 spots. And the first spot, we have 5 possible people that could take the first spot, but then only 4 left for the second, 3 for the third, 2 for the fourth, 1 for the last one. And we could just multiply all that out, or that's the same as 5 factorial. So that would be 20 times 6. That would equal 120 when we're finished. All right. 42 says schedule 1 member to work in the office on each of 5 different days. And let's see, members may work more than 1 day. So we can choose any one of the 5 for the first day. So 5 possibilities the first day, 5 the second, 5 the third, 5 the fourth, 5 the fifth. Okay. So we have all those possible ways we could schedule 1 person to work in the office on each of 5 different days. And we would do 5 to the to the 5th power, actually. 5 to the 5th power, and I'm not sure what that turns out to be, but you could do that on your calculator. All right, select a man and a woman to decorate for a party. So let's assume that Alan, Bill, and David are male, okay? And let's assume that Kathy and Evelyn are female. So we have 3 possibilities. We want a man and a woman, so we have 3 possibilities to choose for the man times 2 possibilities to choose for the woman. So there's 6 ways we could pick a man and a woman to decorate for a party. All right, so on 44, we're going to select 2 members, 1 to open their next meeting and 1 to close it, and Bill will not be present. Okay, one member to open the next meeting and 1 to close it. Okay, so it sounds like 2 different people. Bill's not there, so there's really only 4 people to open it, and then I guess 3 to close it, so that would give us 12. All right, so fundamental counting principle, number of ways to do task 1 times number of ways to do task 2 times number of ways to do task 3, and so on. All right, so a few more they suggested we look at deal with building numbers that have specified digits. Okay, so in this one, we're going to make counting numbers formed by the numbers 3, 4, and 5, and we want to determine the number of different possibilities for each type of number described. So we're only using 3, 4, and 5, not all the digits from 0 to 9, and we're going to create 2-digit numbers. So 2-digit numbers, 2 tasks. So for the first digit, we have 3 options. And then on this one, it doesn't say you can't reuse the number, and with numbers, it would make sense that you could. So there'd be 9 2-digit numbers, 3 choices for the first digit, 3 for the second. Okay. On 46, we're picking 3-digit numbers. And they need to be odd. So if they're odd, they have to end in an odd number. So we only have 2 choices for the ones place, but we could pick any of the 3 for the other 2 places. So that would be 18 possible odd 3-digit numbers. I don't think they'll give you one like 47. Let's try 48. 1, 2, 3, 4, 5. 5-digit numbers beginning and ending with 3. So that means only one possibility there and there. That would be the number 3. And unlimited repetitions allowed. So you could choose any of the 3 for the remaining spots. Okay. So that should wind up being 27. Okay. All right. And then another context is the kind where you're selecting dinner items. So there's 2 soups, 3 salads, 2 different bread choices, and 4 entree choices. And we're trying to find the number of dinners available. 1 item should be included from each of the 3 categories. So I guess they're talking about the categories being these 3 categories. So we have 5 choices of soups or salads, times 2 choices of bread times 4 choices of entrees. So that would be 40 possibilities. Only salad and entree are being included. So salad, there's 3 salads, 4 choices for entree, so that would be 12 possible choices. Okay. 1 soup, 1 salad, and 1 entree are to be included. So 1 soup, there's 2 possibilities for soups. 1 salad, there's 3 possibilities for salads, and 1 entree, there's 4 entrees. So that would be 24 possibilities on that one. Okay. And then 1 soup, 1 salad, 1 bread. We have 2 possibilities for soup. We have 3 possibilities for salad and 2 possibilities for bread. So that gives us 12 possibilities. So fundamental counting principle was what we were doing in this section.